Hello, everyone. This is Professor Felipe Rodriguez. Uh, Today, we're going to be talking about process interruptions, or more specifically, the role that setups and batches have in your production process, right? So let me share my screen. Um, and where did that go? Um, where, how do I share my screen? Okay. Oh, there it is. Okay. Perfect. Here's the PowerPoint slide. And here we go. All right. I always forget how to hide this thing. All right. So here we go. This is MOS 3330 Operations Management. And today we're going to be talking about process interruptions. I will say, though, that this chapter is interesting because it's not very common for operations management textbooks to have a dedicated chapter just in batching and setup times. So I feel like this is a good opportunity for us to engage um, in this kind of discussion. So I'm Professor Felipe Rodriguez from the School of Management, Economics, and Mathematics here at King's University College, Western University, Canada. All right, so let's move on. So where are we? Oh, okay, I'm gonna put it down here. Okay, so process interruptions, batches, and setups. What is the reading for today? This is chapter 7 from Cashon Interruptions Operations Management book, the second edition. I I really enjoy this book. It is process focused. So, as I said before, it is not common to find a chapter just to talk about the role of setups and batch sizes. So this is quite an opportunity. Let's enjoy it. So what are our learning objectives? Well, first we gotta identify setup times in a process. Then we gotta evaluate the capacity uh, of a certain resource now that we have to add a setup time uh, and operating with a certain batch size. So we're going to be talking a little bit more about that very shortly. Then now, because we have a different kind of production process where we're using batches, the utilization changes a little bit. And we're going to see how we measure utilization under that scenario. So we'll be able to evaluate what the average inventory is. And remember, inventory is part of COGS. So if we can evaluate inventory, we can evaluate eventually what will be our gross margin, which is very important. Then we need to find a batch size that minimizes inventory. So here's an interesting thing. I'm making a linkage between the batch size and COGS. And we will see how this is particularly hard to do. Then we're going to find production quantities for each one of the items and explain the different approaches or strategies that you may want to engage given that your process involves batches and setups. So as usual, remember, we're always matching supply with our demand, and we got to do that thinking of our 3Ps: people, planet, and profit. Um, Operations, they are directly linked to your strategy. They enable your strategy. So cost leadership and differentiation have completely different operations. And today, we'll see this, how cost leadership is linked to a, a, a large batch size and low product variety. And differentiation is focused exactly on the opposite side, how we need to have really small batch sizes and really large product variability, right? In particular, what happens is over here, I have high capacity, and over here, I have low capacity, right? We'll be talking a little bit more about those things. You cannot manage what you cannot measure. So as long as you know what your KPIs are, KPIs, you can make deductions as opposed. So if X happens, something happens to X, what will happen to Y? And if you can measure those relationships of cause and effect, you can therefore make decisions and manage them, right? Process triangle as usual. I have capacity utilization, I have durability and inventory, and those things are linked inevitably. And if there is some kind of mismatch, inventory becomes waste, capacity becomes unbalanced, utilization and variability leads to excess variability. Um, I would like to point out that excess variability leads to high inventory and waste, and we want to avoid that as much as we can. Operations is a continuous improvement activity, so there's always a better way. There's always a better way that we can add value to our process. And as I keep saying, operations is not detached from an organization. Particularly with marketing, human resources, strategy, as I said before, and finance. In the case of finance, we're dealing directly with COGS, right? We're talking about process technology, inventory, and direct labor costs. So if we can manage COGS and reduce COGS, we have a high margin organization. So what is really setup time? It's a series of activities that are required to produce flow units, but for which the time to complete these activities does not depend directly on the number of units produced. In other words, sometimes you have to calibrate machines, sometimes you have to clean up your machines, sometimes you have to clean up your workspace, sometimes you have to load different materials, different ingredients, different parts, and those things, they don't directly add any value to your organization. So setup oftentimes is a non-value added activity, right? So if it's not adding any value, you're not making money out of this. You're not improving, you're not creating benefits to your product. Your client and your customer won't see any extra value, and all you're doing is waste time and reducing your capacity, right? So I have the example here. On the left-hand side, this is a good old picture of the 4T model. I apologize, use the good old cliche of, I will produce any color of 4T model as long as it's black, right? And compare that to a Toyota manufacturing plant where you can see different cars, different colors, different models in the assembly line, right? So what is going on over here? Well, we are engaging in completely different production processes, or this is oftentimes cost leadership based. And on the other side, we are trying as much as we can to create value and create differentiation, right? So let's see how those two things play out with respect to process. Most processes are in fact stop and go. Almost never you have a continuous process, right? You always have to do some kind of setup. Um, you know, Sometimes you have to warm up your oven, sometimes you have to calibrate your machine, sometimes you have to change your tools, sometimes you have to change your presses and whatnot. And these happen because you're trying to produce products and services that vary a great deal. So the more variation you have, the more setup you have to do to go to the limit. That's really important. To the limit, okay, as you go to infinity number of products, you will read to infinity number of setups. I know this is kind of hard, but the idea is, and variation in products and services is directly linked to a differentiation type of strategy. And the um, ideal differentiation for a product or service is when it's unique to each one of your customers, right? So you would have unique types of products, therefore unique types of setups. So I would like to mention that variation in products and services are directly linked to a differential strategy versus a cost leadership strategy, right? And observe that what we want to do in this particular time, look at the process triangle: capacity, utilization, variation, and inventory, and see how you can link those two different strategies, cost leadership and differentiation, with respect to the process triangle, right? Um, Differentiation should be linked to value-added activities, unique products. So you will have a ton of setups, right? Cost leadership will lead to economies of scale. You need to, you're not worried about creating as much value to the customer. You don't want your product to be unique, right? Uh, you don't want customization. What you want is the lowest cost. So you're going to be making money out of high volume. High volume means large batch sizes. How does that fit into the process triangle, right? As opposed to high variation in products and services. So here we go. This is an example from the textbook where you have a process flow, you have a milling machine and the assembly. The assembly, you're assembling one unit every single time, but the milling machine is milling 4 units at a time, right? So this is a batch. I don't produce 1 unit at every activity, at every task. I'm producing multiple units at every task, right? So the ideal process with setups um, has to be fast and consistent in pace. The idea here is predictable, reliable, and fast, right? Unfortunately, the more you have setups, the less likely you'll be able to figure out the best capacity for your process. So here we go. A few things that are important when we're talking about batches and setups. The first one is what we call the production cycle. This is a repeated sequence, and it includes a setup time, a production time, and sometimes a idle time if your process is not balanced, right? So one production cycle, in this particular example, I have two sets of parts. I have steer and ribs, and a production cycle will set up my machine to produce steer supports. Then I set up, produce. Then now in the same machine, I have a different setup for those ribs. I produce those ribs, and when I initiate a setup to go back to the steer, this means one production cycle, right? It's the repeated sequence, and this is going to repeat all over again, right? Now, what is a batch? A batch is a collection of units. A batch will necessarily mean that you have some kind of a group. Units are produced in groups, right? And a classic example, so I apologize again for the cliche, it's the cookie tray. So you don't bake one cookie at a time in your oven. You put a whole bunch of cookies in a tray, a group of cookies, you make a batch, right? So every time, every 30 minutes or so, a new batch of cookies comes out. That's what we're talking about. Now, let's talk about capacity and flow rate of a process. Capacity depends on batch size. So every time we're talking about capacity, we're talking about the number of units produced divided by the time it takes to produce them, right? So for example, 300 units per hour. This is a capacity, right? Now, think about this for a moment. You're setting up your process, therefore your capacity should be fixed. And every time you look at a process with multiple stages, the capacity of that process is equivalent to the the smallest capacity in the process, or the slowest cycle time, right? So that's your bottleneck. So the smallest capacity will determine the pace of your operation. Now, before we continue, let's talk a little bit about this for a moment. So if you have a batch size, I can say that my capacity should be related to the batch size, right? And the batch size is the number of units I'm going to be producing. So I'm going to call batch size B, right? Now, what is, in fact, the time that it takes to produce those units? Well, I'm just saying now we have a setup time that has just been introduced. And we also have a processing time. So it should be linked. Capacity should be linked to the number of units produced. That's your batch, right? Divided by the time to produce those units. So your setup plus uh, P, which is your processing time, right? And you're producing a group of units at the same time, so you gotta multiply this by the batch size again. So let's see if this makes sense. Batch size is units, setup is in time, all of this plus processing time is time per unit, and batch is units, right? So let's see if it makes sense. This cancels with this, T and T, so you end up with units per time. There we go. We have it right there. So this makes sense. Now, wow, look at it. I just did that equation by intuition. Here's the equation again, formally introducing the capacity with respect to batch size and setup times. So let's look at this equation and get some intuition behind this equation. What really happens if I increase my setup time? If this goes up, what happens to my capacity? So setup time only shows up in the denominator, right? So the more time I spend dealing with retooling, dealing with recalibrating, dealing with preparing, cleaning up, and whatnot, the less time I have available for production, right? So the setup, it makes sense. If this goes up, capacity will go down because I can only have so many hours in any given day. The number of hours is fixed. If I spend too much of that time setting up my process, I won't have enough time to actually produce anything or to service my clients, all right, my customers. So as setup increase, the capacity decreases. Now, so this makes sense. Now let's see what happens if my processing time increases. In other words, if I have a production process in which the time it takes to process one unit through a step of my production process increases, right? So I'm making a slower process overall. If my process becomes slower, processing time going up. So this means that the denominator increases, so my capacity decreases overall. And last but not least, what happens if my batch size goes up? Well, let's look at batch size. Batch size happens over here. So you're increasing your denominator, but this is being multiplied by time. So let's see. So batch size is units. Total setup time is time. Processing time is time per unit, like I showed before, and batch size is unit, right? So I'm going to cancel this with this. So the batch size in the denominator won't necessarily matter much, but this guy will still increase. So if this guy, the numerator increases, therefore you have a increase in capacity. So big batches increase capacity. The only problem with that is a big batch will also increase inventory. And we're going to be talking a little bit about that too. So to wrap this up, a lot of setup time, your capacity decreases because you're allocating a fixed amount of time in a day to setup as opposed to production. On the other hand, a processing time, if you increase the processing time, you make a process longer to finish a product or a service, you can, again, in a fixed amount of time, you can only produce or service so many units a day, therefore your capacity goes down. Now, if your batch size, on the other hand, increases, your capacity increases. Just think about the cookie tray that I mentioned before. If you have a huge oven and you put a huge cookie tray, your capacity to produce cookies in 1 hour will increase for just for the sake of having a bigger batch size. So now, few things change when you add setups, and one of them is the utilization, right? So a process with setup times will not be producing all the time. There will be downtime each time a process requires a setup, right? Um, you may also have idle time if your process is not well balanced, right? So if I have 3 processes, this is how long it takes, this is how long it takes, and this is how long it takes. So it depends on what's going to be happening right here will determine how much idle time your process may have, right? So let's move on. The utilization now that includes setups must be thought as if a utilization only when you are in fact producing something, right? So originally, utilization is flow rate divided by capacity, right? Now, if my capacity is production capacity, setups should not be included. The utilization, therefore, should be the output rate only when I'm producing. In other words, let's think about this from this perspective. If the utilization is the flow rate and the output rate when producing, what I'm talking about here is I'm talking about processing time, right? So the output rate when producing is 1 divided by processing time. So rate divided by 1 divided by P is actually rate times P. So this is an interesting concept. Your utilization is your flow rate times your processing time. This is very different than inventory equals your flow rate times your flow time. Flow time, we now know, includes P, includes setup time, and includes time in queue. Remember that? So my utilization revolves only around my processing time. And what happens if P goes up? If your processing time takes too long, what do you get? You have a high utilization, meaning, for example, this is your barber shop. If you take too long to service your customers, you're going to be busy all the time, right? So, and the same thing with flow rate. What happens if your flow rate increases, right? So what happens if your demand goes up? For example, your utilization will also go up. So that's a key intuition that we have to think in terms of utilization. Slow processes are busy all the time, and high demand processes are busy all the time. So capacity and utilization increase as the batch size gets larger. Now, why is it? Why is it that we don't always operate with really large batches? Well, if you want high capacity and you want to operate um, at high capacity, why not just have huge batches? Well, because we will, if we have a large batch size, that also means we will have high inventory. Oh, no, sorry about this. Just a second. I didn't mean to write H. I meant to write. I meant to write inventory. There you go. High inventory. That is the key. And high inventory means high COGS. Also means a high accounts payable, which means a really bad cash flow, right? So you should not be thinking in terms of let us just have the biggest batches we can think of, because that will create lots of inventory. Go back to the cookie example that we had before in the bakery. If I have a really huge oven and I bake a ton of cookies every hour, I will have lots of inventory, and if the demand doesn't realize, that inventory will eventually go to waste, right? So you don't want to do that. In the case of goods that aren't perishable, or as a matter of fact, um, uh, quite many examples of that, you would have a large inventory that you're going to be carrying for a long time. So there's holding costs of inventory included there. You don't want to go into that situation. So really large batches increase inventory and therefore reduce your margin and increase your accounts payable and reduce your cash flow, right? So maximum inventory calculations. If inventory is so important, let's see if we can find a way to figure out what my maximum inventory would be and what my average inventory is. If my intention is to make decisions with respect to trying to reduce my cost of goods sold, I need to be able to calculate these things, right? So let's look at these two charts. On the x-axis, I have time, right? So time is going this way. On the y-axis, I have units. Same thing for this chart over here. Now, we have two products here, steer supports and ribs. This could be anything, just two different kinds of products. What I would like to show to you is, let's see if we can get some intuition around this. For example, in this graph over here, I'm at roughly 45 units of maximum inventory, right? So my production run, my batch is 45 units. This guy also 45 units, give or take. Okay, so you can see this is a triangle, right? So let's get some intuition around a triangle. Triangle is half the area of a square, right? Let's have that idea in our minds right now. So if I have a large batch, I have a large triangle over here, my inventory is way larger. So by intuition, large batch sizes will give large inventory. In this case, your maximum inventory, right? And we will beat some intuition around that this also increases your average inventory overall. So how is it then that we can reach to that situation, right? So cookie tray is a good example. Let's think about other examples. For example, a concert, the more people that comes in, that being your flow unit, the larger the inventory. A movie theater is the same way. A car manufacturing plant, a computer manufacturing plant. The whole idea behind these things is small batch sizes reduce your inventory, while large batch sizes increase your inventory, right? So, and remember this thing that I mentioned before. A triangle is half the area of a square. So what kind of triangle are we talking about over here? Well, the base of this triangle is time, and the height of this triangle is units, right? So if I want to figure out what will be my average inventory, maybe my average inventory will be half the area of this square measured in terms of time and units, right? So let's think about this for a moment. My average inventory will be half of my max inventory over there. Let's think about this, okay? So how do I calculate my maximum inventory? Well, I know that my inventory relates to batch size and the time it takes to produce that batch size, right? So batch size times processing time. This is just basically the amount it takes to produce um, one run. And now the second item of this equation, this is interesting. 1 divided by processing time, this relates to capacity, right? And flow rate, this relates to demand. So the difference between your capacity and your demand, this is what we call a buildup. So this is by how much your inventory will grow over time. If my capacity is 100 units per hour and my demand is 90 units per hour, if I keep producing things every hour, I'm going to build up 10 units of inventory. So going back to that chart where we're building up inventory, right? So that's that ratio that we're talking about over here. So I can simplify this a little bit more. 1 divided by processing times minus flow rate. I have processing time over here too. So I can think about the same equation in a simpler format, right? So batch size times 1 minus flow rate times processing time. Now notice that this thing over here, so I have a minus 1 minus whatever this is. So this guy is always, less than 1. So I'm building up rate, right? My building up rate is 1 minus something that is inherently less than 1, right? So this part over here will give my buildup times my batch size. That will give my maximum inventory. So the rate in which I grow by how many units I need to grow. There you go. And like I said before, the average inventory will be the half of your maximum inventory. So these equations, they tend to simplify things a little bit if we try to build some intuition around them, right? So I have a build-up rate, and then I have a number of units that I intend to produce. So if I intend to produce something that is great, what happens now? How do I figure out how much I need to produce? That will be your target capacity. And target capacity is different than your overall capacity, right? So this relates to your demand. So what do I want my demand to be? So I can match my demand with my capacity. That's what I mean. So we've seen this formula before, the batch size divided by the total setup plus batch size times processing time. So this is not necessarily new, right? But the interesting thing is, if I know my demand, I can define what my target capacity is, right? And so I can fix this guy. I can find my setup time, and I know my processing time. I will find my batch size. Excellent. So what you can do is solve this with respect to batch size. So it's the same equation, but now I'm solving this for batch size. And this will help me minimize my inventory. So let's look at what happens with respect to the batch size again. If my target capacity goes up, my batch size will also go up, right? If my processing time goes up, so this thing becomes larger. So this number, so 1 minus something really close to 1 is a really small number, so the denominator will go down, right? Uh, so what we need to think about this, sorry, I have something divided by a really, really small number. This will make my batch size always also go up, right? And we know from before the setup time. If the setup time goes up, then my batch size always also needs to go up, right? So that's the intuition behind these formulas. So setup times often occur during to change in production. In other words, this is increasing product variability. This is a differentiation type of strategy, right? Small batches lead to frequent switchovers, which leads to low capacity, which is okay if you're trying to create value to your client, if you're trying to create differentiation, if you're trying to make something unique, right? Something unique, a product that is customizable, a service that is customizable, you can charge more for it. And as we've seen before, large batches generate higher capacity, but may result in excess inventory. So here's an interesting example that we have from the textbook. And I like to talk about this example because it kind of shows us that trying to find a differentiation strategy sometimes can be rather troublesome, right? So let's have in mind these two equations over here, batch size, maximum capacity, and also, no, sorry, maximum inventory, and also our average inventory being half of the max, right? So that's important. So here's a company that can produce 300 gallons of soup per hour, right? So this is their current production capacity. So their processing time in terms of gallons of soup per hour is 1 divided by 300, right? So this is hours per gallon. Excellent. So here's the demand that I have right now. Chicken soup and tomato soup. Let's look at this first scenario where I only have two products, chicken soup and tomato soup. This is their demand. All right, 100 gallons of chicken soup, 75 gallons of tomato. So my total demand is 175. This should be my target capacity, okay? So if I know what my target capacity is, I know what my processing time is, all I need to know now is my setup time, and Um, for this one particular example, the book says that the setup time is half an hour per batch. Okay, so now I have all the information I need to figure out what the batch size will be like. I have my target capacity, I have my total setup time, I have my processing time. And what happens in this situation is that when I solve for this equation, I reach a batch size of 420 gallons. All right. Now, think about this for a moment. If 420 gallons is my batch size, how much of this will be chicken? Well, I know that chicken is 100 gallons out of 175. So 420 times 100 divided by 175 gallons will give me 240 gallons. There you go, right there, right? And the difference, same thing, 420 times 75 gallons divided by 175. This will give me 180 gallons, right? So this is how much I should be producing every production cycle, all right? So I have a production cycle here that includes one setup and one production, one setup and one production. The first one chicken, the second one tomato soup, right? This takes half an hour, this takes half an hour. This production cycle will be for 420 gallons, right? And this is how they're going to be divided. Excellent. So now I can also calculate what my average inventory is because I know what my batch size is, I know the flow rate, and I know the processing time, right? So by calculating all that, I know that my maximum inventory is 190 for this guy. So my, 160 for this guy. And so the average inventory for chicken becomes 80, right? Same thing with, I can do the same kinds of calculations with the tomato, and my total average inventory is 147 gallons. Now let's see what happens. Let's see what happens when I introduce onion soup to that mix. I'm introducing 30 gallons of onion soup. That's the demand um, that has been introduced to my system. So let's see the impact that that has. So overall now my demand, my target capacity becomes 205. And if, let me erase these calculations right here for a moment. Okay. So if now my target capacity is 205, what should be my batch size? Well, batch size will be, the target capacity is 205 times the setup time. Setup time is half an hour for each product, so times 1.5 hours per batch, right? And down here I have 1 minus 205 times 1 over 300, which is the processing time for each gallon of soup. So this is going to give me, as you calculate all of this, this will give you 971 gallons. Look at this. We went from 420 to 971 gallons. That's the size of your batch, right? And you can make the same kind of ratios, and then you're going to find now out of those 971, approximately 474 will be chicken, 355 tomato, and 142 will be onion. But observe what happens to inventory. So because we increased our need, our target capacity, our batch just became huge. And you can use the same maximum inventory and average inventory formulas, and you will find that your overall average inventory is 355 gallons. So it almost doubled, right? So by adding plus one more product, your inventory doubled just by adding one more product. So, okay, you may want to think, well, you know what? Maybe your demand is fixed. It's always 175. So by adding 3 units over here, you're going to be decreasing the demand for the other kinds of soups. So you keep 175 constant. Fine, let's do that. So instead of 205, oh, sorry. Oh, geez. Where am I? Oh, there you go. Instead of 205, now let me use a different color. This is going to be, what was that again? 175, 175, right? And what you can do with your different products is you will find that the average inventory now, the average batch size will again go down, right? But it's still way larger than it was before. And sorry, your production cycle, right? And also your inventory will also go down. So as you can see, this is becoming very polluted. I apologize. Let me take some of these things out. So as you can see, the big takeaway from this is that by increasing product variety, you are also increasing inventory, right? You're increasing your batch size. So why is it that you want to have all these setup times? What would be the reason for someone to be thinking in terms of adding your setup times? Well, the whole idea here is differentiation. That's the strategy you're looking for. The example of Legos. Can you imagine how many different kinds of bricks that Lego has to manufacture, and so many kits that they currently produce? Their strategy is directly linked to differentiation, to having more and more products so they can appeal to more and more kids and can charge better and better prices, right? So having setup means I'm trying to achieve a differentiation strategy. Therefore, I need to create many, many products. I need to create variability. And a huge portfolio of products, so I can satisfy the tastes of my consumers and charge a premium for that, right? Remember, always at the expense of lower capacity and perhaps larger, uh, sorry, always at the expense of lower capacity. So how is it that one can achieve a differentiation strategy that doesn't compromise your capacity so much because of all those extra setups, right? The Japanese and Toyota and the Toyota production system came up with the idea of a single minute exchange of die. So they're talking about retooling of their machines. And the idea here, this is actually a single digit. So they wanted to reduce their setups to less than 10 minutes. So it should be less than 10 minutes, any kind of setup to any stage of the process, right? So Ford was thinking in terms of, I can sell any color car as long as it's black, so I wouldn't have any setup with respect to the paint shop, right? Toyota, on the other hand, is trying to think of ways, how can I reduce my setup times? What are the strategies behind? And every time you hear about SMED or SMED, you're going to be thinking in terms of the pit stop at a racing car, where people are very specialized, and most importantly, most of the work that needs to be done to set up that um, that car to a new uh, um, to the remainder of that race is done in advance, right? So they put the tires really close, they put the fuel really close, they have the cleanup equipment really close. When the car comes along, the racing car comes along, everything is done super, super fast, because a lot of the work was done in advance. So there are some internal setups that it's really hard to change unless you're changing the structure of your machines and your tools and whatnot. It will be really hard. But external setups, once you find which ones can be external, you can pre-assemble, you can pre-calibrate, you can pre-process everything externally. And when the time comes for the setup, all you have to do is link that pre-assembly to your equipment, right? So activities that can be done while the production continues to occur. So when a machine is working, that's an internal setup. You can't really do anything. You know, the racing car is racing. You can't change the tire of their car when the car is racing, right? But some external setups can be done. You can prepare the tire, you can put the tire in place. When the car comes for the pit stop, it's really easy to make those changes. So once you find what is internal, once it's working, you can't change. And what's external, you can therefore focus on the external tasks. Make sure that these are done before outside of the dedicated time for your setup, right? So the Japanese and the Toyota production system also looks from the perspective of smoothing the flow. And that's an interesting idea, right? Where you have an assembly process that, because of really short setups, because these setups are really short, right? I can match my production for the true rate of demand. So instead of having huge batch sizes, for example, this guy over here, a whole bunch of product A's, then a whole bunch of product B's, then a whole bunch of product C's, then a whole bunch of product A's again. This is my production cycle right there. Huge production cycle with only let's see, how many setups do we have here? I have 1, 2, 3 setups over here, right? What I will do is reduce the amount of time for these setups, and I will have small lot size, small batches that will match what my demand should be. So we just figured that out using the batch size formula. So how many of each unit should we be producing on every single production cycle? So if you match your production run with your rate of demand, a lot of things will happen that will be very beneficial to you. First and foremost, you're going to be more efficient, right? So you are reducing your setup time, increasing your production capacity, while at the same time allowing you to have greater variety, right? So here's where Ford was, very efficient, but only black Ford T cars, right? And then you move to where the Toyota production system is trying to achieve, which is, oh, sorry, let me erase this thing here. Apologize. Didn't look good. Sorry. There you go. So here's Ford with high efficiency and low variety, right? And as you reduce the amount of time and you try to match the rate of demand with your production capacity with smaller lots and really fast setup times, not only you become more efficient, but also that allows you greater product variety, right? So that is the idea. High efficiency with increased product variety by matching your production with the true rate of demand because you have short setups, right? So in conclusion, the ideal process is not only fast, and by fast, I'm also including fast setups over here, but also at a consistent pace. It's predictable. It's reliable. Okay? Long setups need large batches to compensate for low capacity. So if it takes too long for a setup, you need to produce all at the same time, right? Large batches lead inevitably to higher inventory, and this impacts your COGS, which we should be very, very careful with. And product variability leads to lots of setups, which leads to lower capacity. So the key here is the kind of strategy that you're looking for. A differentiation strategy inevitably will have high setups. That will just happen. So part of your decision-making process is to make sure that these setups are really, really fast. The faster they are, the better off you will be, and therefore you can compensate for your demand. On the other hand, if you're looking for cost leadership, you're not gonna have a lot of setups, right? And you can work on big batches. By working on big batches, you can increase your capacity and have economies of scale. You make money on volume, not on quality or differentiation. And again, the problem with big batches is it increases waste. And there's only two things that we can do with this, well, two most important things that you can do with respect to setups and batches and product production process interruption is you either reduce your variability or you reduce your setup time. Reducing variability only works if you're thinking in terms of cost leadership. A few products in large scale so you can sell at a cheap price and make money on volume. Or you keep or increase your product variability, but you reduce your setup time, such as with SMEDs, right? And the strategies that go around this is you can, for example, pre-assemble things with your supplier. You can you can pre-setup the external setups for any kinds of steps, right? So think about the operating room when you have the carts, so all the tools are done already. Each kind of surgery already has its specific tooling already set up, right? You go to the dentist, it's the same thing, and so forth. So pre-assembling, processing the setup in advance to a new product cycle will help you speed up and increase your capacity. So that's it for today. Thank you very much. I'm Professor Felipe Rodriguez. If you have any questions, send me an email. This is MOS, the MOS 3330, Operations Management from the School of Management, Economics and Mathematics at King's University College, Western University. Thank you all very much. See you next time.